Hello and welcome. Let me first introduce you to the course of Engineering Drawing. Engineering Drawing is a course taught to the engineering undergraduates in the first year. This course has a credit weight of 4 and has an engagement of 2 hours of lecture and 4 hours of tutorial component. The tutorial component includes 2 hours of manual drafting component and 2 hours of automated drafting component. The lecture tutorial combination is to ensure that the concepts discussed in the lecture class are practiced in the tutorial class so as to cement the concepts. As far as the course syllabus is concerned, it can be accessed using the following link. In this session, we are going to first acquaint ourselves with the basics of engineering drawing. In this process we will address the basic questions like why we need engineering drawing, who needs it, what are the underlying principles and essential elements of engineering drawing. We will extend the discussion to the conventions used in engineering drawing. There are a number of books recommended for this course. Amongst these, the textbooks recommended for this course include Jalhi, D.A., Engineering Drawing. Tata McGraw-Hill, 2008. Gill, P.S., Geometrical Drawings, S.K. Kataria and Sons, Delhi, 2008. Davies, B.L., Yarwood, A., Engineering Drawing and Computer Graphics, Van Nostrand Reinhold, UK, 1986. Other reference books include Gill, P.S., Machine Drawings, S.K. Kataria and Sons, Delhi, 2013. Mohan, K.R., Engineering Graphics, Dhanpat Rai Publishing Company, P. Ltd., Delhi, 2002. French, T.E., Vierk, C.J. and Foster, R.J., Fundamental of Engineering Drawing and Graphics Technology, McGraw-Hill Book Company, New Delhi, 1986. Rowan, J. and Sidwell, E.H., Graphics for Engineers, Edward Arnold, London, 1968. Drawing is one of the oldest forms of human expression within the visual arts. It is believed that drawing was used as a specialized form of communication before the invention of the written language. That brings us to the question: what is drawing? A drawing is defined as the art of representation of the real shape of an object by means of lines on a piece of paper. In general, drawing concerned with the marking of lines and areas of tone onto paper, where the accurate representation of the visual world is expressed upon a plane surface. This slide shows some of the examples that fit into the definition of drawing, where each image shows a different type of art form. All these images are an outcome of marking of lines and areas of tone onto paper. After having discussed the term drawing in general, we shift our focus to an important question. What is engineering drawing? Defining engineering drawing, one could say that engineering drawing is a technical drawing that is used to convey information about a product. It is also defined as a graphical representation of an engineered product on a piece of paper or on a computer. That brings us to the next question: why do we need engineering drawing? In engineering, drawing is the principal means of communication. It is a tool that is used to impart ideas, specify shape of an object or simply to convey information about a product. Drawing, therefore, is considered as the language of engineers. Just like any other language, engineering drawing is governed by rules and conventions, which vary only slightly from country to country, but the underlying principles of engineering drawing remain standard. With the ever-increasing exchange of goods, services, and information across the globe, drawing has become a powerful tool of communication. This slide shows some of the examples of engineering drawing, where we clearly see specificity in the drawing with regards to the shape and size description of the object being considered. In the first image, one can see an assembled drawing of a bicycle. The assembly drawing has all the dimensions marked on the drawing. The second image pertains to the finished drawing of a machine component. In the second drawing, in addition to the three-dimensional representation of the machine component, dimensioned drawing showing the three views of the components is also shown. This brings us to the next question. Who in the industry needs an engineering drawing? Engineering drawing is one of the most versatile tools of expression of ideas and communication. Practically, every engineering discipline uses engineering drawing. So, one can easily conclude that the outreach of engineering drawing is ubiquitous. Almost all engineering professionals create and use engineering drawing in one form or another. The design and production drawings are created and used by mechanical engineers, wiring and circuit drawings by electrical engineers, functional flow block diagrams by electronic engineers. In addition, structural, site development and landscaping drawings are created and used by civil engineers, architectural and perspective drawings by architects, animation and graphics design by computer engineers, and plant design and process layout drawings by chemical engineers. Now, a brief history of engineering drawing in the Indian context. Post-independence, in 1955, the Bureau of Indian Standards issued IS 696 as a code of practice for general engineering drawing, a document that contained all the rules and conventions specific to India. This document was revised twice, once in 1960 and then in 1972. On completion of the second revision, IS 696 was withdrawn and a new educational material was formulated in 1988, under a new code SP 46, to cater to the requirement of engineering students in India. Every engineering drawing has two significant things to convey: the geometric shape of the object and the related dimensions of the object. So, any engineering drawing has two essential elements: shape description and size description. For shape description, a combination of lines, arcs, circles, etc. are brought into use to depict how an object looks like. In order to lend specificity to the shape description, every shape description of the object is complemented with size description that includes dimensioning, labeling, or recording of notes on a particular drawing. In order to describe the object in totality in engineering drawing, different types of lines are used. Each type of line used in engineering drawing conveys a meaning and is attributed to depict object-specific information. In addition, each type of line has a convention for its representation, in which the terms thin and thick refer to the weight or thickness of the line. The different type of lines include object line or outline. These are thick continuous lines used to depict edges of an object that are directly visible to an observer viewing the object from a particular angle. Hidden line. These are thin short dashed lines that may be used to represent edges of the object that are not directly visible to an observer viewing the object from a particular angle. This is generally due to the opacity of the object. Center line. These are thin, alternately long and short dashed lines that are used to represent the axes of circular features in an object. These lines are also used as lines of symmetry. Section plane or cutting plane line. These are light, alternately long and short dashed lines with heavy ends that are introduced to exhibit a cutting plane. Usually, both the heavy ends are supported by arrows, pointing in the direction of the lines of sight of the observer. Section or hatch lines. These are thin continuous lines in a pattern used to indicate surfaces resulting from cutting, where the pattern is determined by the material being cut or sectioned. Dimension lines. These are thin continuous lines and are terminated at their outer ends by pointed arrowheads, touching the extension lines or center lines. These lines are used for marking dimensions in a drawing. Short break lines. These are thin, wavy continuous lines drawn freehand and are used to show short break or irregular boundaries. Long break lines. These are thin lines with short zigzags within them. These lines are generally drawn to show limits of partial or interrupted views. In addition, we also use construction or projection lines. These are thin continuous lines used for constructing figures in different views. All the types of lines that have been discussed have been represented, using an example of a machine part. As one can see to the left of the screen, two three-dimensional representations of the machine part have been shown, first showing the entire object and the second showing the effect of introducing a cutting plane through a part of the object. In the second three-dimensional representation, one can see the hatch lines that show the new surface generated by the cutting plane. To the right of the screen, two views, front and top view of the object have been drawn, using different line conventions. So, whenever we indulge in drawing of an engineered object, we must take cognizance of the different line conventions to truly reflect the image of the object as seen from a particular direction. We will be extensively covering the use of different line conventions as we progress in this subject. In engineering drawing, any shape description must be complemented with appropriate size description. This deals with information regarding the specifications of the engineered product. This may include length, width, height, position of holes, grooves, etc. Adding such information on a drawing is called dimensioning. As far as the dimensions are concerned, the unit of dimensioning is millimeters. While writing the dimensions, one should ensure that only the dimension values are written alongside the drawing. In general, we have two types of dimensioning. Size or functional dimensioning that indicates the length, width, height, diameter of the object, and location or datum dimensions that indicate the relative position of object entities. To clearly understand the types of dimensioning in engineering drawing, we use the example of a three-dimensional drawing of a cuboid. This cuboid has two holes of different diameters drilled through the top surface. As one can see, the dimensions highlighted in red indicate the functional dimensions and the ones highlighted in blue indicate the locational dimensions. Another type of line used for dimensioning is a leader line, which is used to refer to some feature of the object like the diameter of a circular hole. Leader lines are used when the dimension text does not fit next to the corresponding entity. While using the dimension line convention for dimensioning a drawing, it is important to ensure that the extension line, that marks the starting and terminal point of a dimension, is marked and that the arrowheads used for dimension line are in the ratio indicated, that is either 1:3, where 1 is the width and 3 is the length of the arrowhead. In engineering drawing, there are two systems of placing dimensions. One is termed as the aligned system, and the other is called the unidirectional system. In aligned system, the dimension is placed perpendicular to the dimension line in such a way that it may be read from the bottom or the right-hand edge of the drawing sheet. The dimension should be placed near the middle and above, but clear of the dimension line. On the other hand, in unidirectional system, dimensions are so placed that the whole dimension is written in the same direction in the entire drawing, and this direction is generally vertical. While dimensioning, it is necessary to observe certain conventions. Some of the conventions are: a circle should be dimensioned by giving its diameter instead of radius. The dimension indicating a diameter should always be preceded by the symbol phi, as seen in first figure. If there are more than one hole of the same diameter, each hole need not to be dimensioned separately. In such a case, the dimension of a hole with a note will give an idea about the dimension of all the holes, as can be seen in second figure. Square features, example a rod of square cross-section, are dimensioned using SQ, as can be seen in third figure. In this slide, we show some of the recommendations that need to be followed while dimensioning a drawing. Extension lines and leader lines must not cross the dimension line. As illustrated in first figure, extension lines should be drawn from the nearest points to be dimensioned. As illustrated in second figure, extension lines of internal feature can cross visible lines without leaving a gap at the intersection point. As illustrated in third figure, do not use object line, center line, and dimension line as an extension lines. As illustrated in fourth figure. The next slide shows additional recommendations regarding dimensioning a drawing. Avoid dimensioning hidden lines as illustrated in fifth figure. Place dimensions outside the view, unless placing them inside improve the clarity as illustrated in sixth figure. Dimension lines should be lined up and grouped together as much as possible as illustrated in seventh figure. And finally, do not repeat a dimension as illustrated in eighth figure. At the very outset, it was explained that in this course of engineering drawing, the tutorial load is split between manual drafting and a computer-aided drafting component. Now, we discuss the different instruments that are required for manual drafting. As you can see, first we have a drawing board, which is a rectangular shaped board made of various sizes, and its selection depends upon the size of the drawing sheet. Usually, the drawing board is made from seasoned wood. On the top left corner, a drafter is fixed in such a way that it can sweep across the drawing board. A drawing sheet is set up on the drawing board with the help of a cello tape or clamps. Next, we have a mini drafter, which is an instrument that adopts the functionality of the set squares, scale, and the protractor, all rolled into one. It has one end is clamped to the drawing board. At the other end, an adjustable head, having a unified protractor marking and two blades, at right angles to each other, is fitted. Each blade is graduated and serves the purpose of a scale. The two blades may be set at any desired angle with the help of protractor markings. The mechanism of the drafter allows the two blades to sweep across the drawing board and be adjusted at any angle. Moving on, while drawing, it becomes necessary to draw lines of uniform thickness. As such, the selection of a pencil becomes important. There are a variety of pencils used, ranging from soft to hard. Each pencil has a grade, ranging from 9H to H and from F to 7B. For engineering drawing, the recommended pencil grades are H, 2H, and HB. Other instruments required for engineering drawing are usually available in the instrument box or the geometry box. These include drawing compass, a divider, set squares, and a protractor. In addition, a dust-free eraser and a good sharpener is also recommended. Another accessory that is required is a cello tape that helps fixing the drawing sheet to the drawing board. This completes the information about the different instruments used in the manual drafting component of engineering drawing. Welcome to Introduction to AutoCAD. First, let's understand what is CAD. CAD stands for Computer-Aided Design. The use of computers in geometric modeling, drafting, and analysis of products is termed as computer-aided design. CAD software is used to increase the productivity of the designer, improve the quality of design, improve communications through documentation, and to create a database for manufacturing. CAD may be used to design curves and figures in two-dimensional space, or curves, surfaces, and solids in three-dimensional space. Different CAD software that are used for this purpose include Creo, AutoCAD, SolidWorks, Unigraphics, Inventor, etc. AutoCAD is a commercial computer-aided design and drafting software application. It is developed and marketed by Autodesk. The core strength of AutoCAD has been 2D drafting, but nowadays it can be used for 3D modeling as well. AutoCAD can be used for generating automated drawings, required in areas like engineering, architecture, interior designing, facility planning, company logos, maps, diagrams, schematics, and many more diverse applications. The drawings generated using AutoCAD can be stored in a database for documentation, subsequent retrieval, editing, customization, and automation. Now, let's see how to install AutoCAD on your computer. The minimum system requirements in order to install AutoCAD, with respect to the operating system, CPU type, memory or RAM, and display resolution, are given in this table. For other details, the website autodesk.com can be visited. The steps to be followed, in order to get a free educational license of AutoCAD LT 2017, or higher versions, and install it, are presented here. AutoCAD LT is the light version, and offers two-dimensional capabilities, whereas AutoCAD has three-dimensional functionality. First, open the given link, and create a new account with Autodesk, on this website. After signing in this account, click Download, and choose the Windows and AutoCAD version you want. Do remember to note the serial number and product key, as you will need these to authenticate the download. After the installation is complete, your selected AutoCAD version should be ready to use. The interface of the software, and the different features and commands used to generate the two-dimensional entities in a drawing, would be discussed in a subsequent video.